And go where it says more practice with adjusted R squared. And we're going to get to some handouts later that I told you guys to bring in. It says problem 919. I guess we're going to do that, but the data that you're going to need is called DEBT, D-E-B-T, and I put it there for you to just download. I don't want to have you waste time putting in the data. So open that file, DEBT. It's like an Excel file. Open that, and that's what we're going to work on together. That's what we're going to work on together. So open that, get that ready. Before we actually do it, so you can see from the file there's a Y column and there's 3 X columns. So before we actually do that, I want to make clear that, okay, if you get a problem that asks you which model is the best, that's kind of where we are now. And we kind of discuss what model means. Which model is the best? That means I have to do multiple regressions a number of times. So looking at this data right here, look very closely. Can you look at the data, just the data itself in Excel, and tell me how many different regressions are you going to run in this problem to answer the question? Think about that. Think about that. Because in an exam, I'm not going to tell you how many to run. You're going to have to be able to know how to look at the data and tell me how many different regressions you're going to run to tell me which models are going to be better. Because when I was grading some of your, looking at some of your homework, I was noticing that some of you were running different regressions, but you were using the wrong thing in it. Okay. Type in the chat box how many different regressions you think we're going to use. How many do you think we're going to run in this particular problem? If I say, tell me the model that's the best model. It's going to be kind of not a lengthy process, but you're going to have to know how many you're going to have to do. Okay. All right. So let's see here. All right. Okay. So some of you are saying 4. Okay. Now I want to try to get at the answer without doing the regression yet. Tell me, or write down, not in the chat box, but like on your own paper, write down the different arrangement of X's you're going to use to do it. All right, so it's looking like most of us are saying run 4 different regressions. Okay, so now what I want you to do is write down X variables that goes with the first one, the second one, the third one, and the fourth one. Because I started noticing some common errors. So I said, well, let me just kind of go over this again. You're going to run 4 different regressions, and we'll kind of get at why certain people think 4 in a second. But just write down what are the arrangements that you're going to have here. Okay, so let's see. Tara, why did you say 4? Like, what's going through your mind? How did you arrive at that number 4?
Honestly, I'm not gonna lie, like I wasn't really sure. I never.
Okay. All right. Michael, any idea? Where's that 4 coming from?
I think it's because, like, do you want me to say, like, the only way I know how to explain it is to say the ones.
Okay. Yeah, okay, yeah. So in other words, you want to tell me what these are right here?
Sure.
Okay, yeah. What do you have?
X1, X2, X2, X3, X1, X3, X1, X2, X3.
Very good. Very good. Very good. Right? So in other words, if I'm starting off, so in your data, you have y, x1, x2, x3. Okay, so that's the original data on the Excel sheet. But what I have to do is do the different permutations or arrangements whereby I'm hitting all of the variables there. Now, notice what is left off. Now this is kind of like a higher order thinking. What did I not write here that some students may think I should write? And anybody have an idea what I'm asking? Like, give me one that somebody may think should be there that's not there. Yeah, who is this? Yeah, who is this?
Would they think 2 and 1, but x2 and x1, but you don't have to do that because you already did x1 and x2 in the first one?
Oh, okay. Well, okay. So that's good. I wasn't thinking in that way, but you're exactly right. If you have x1, x2, then that's the same thing as x2, x1. That's very good. Very good. Who else? Oh, okay. All right, Lydia. Perhaps they think the y has to be added on here, like x1, x2, y, x2, x3, y. Okay, so that's a good way of thinking. Now, so notice here that none of these include the response variable. Okay, so make sure you're not putting y there when you're doing it, because see, all of these here are going to be used to predict y. So in a sense, indirectly, the y is there, but I'm not going to add it in terms of the different combinations here. All right. Here's a common thing that I saw on your labs. People, when you were doing these different arrangements here, one of their options was just x1 by itself, or x2 by itself, or x3 by itself. Who can debunk that theory of why you should do or why I should not do that? Why should I not be doing x1 by itself, x2, then x3?
Because you need to compare it to another set to see if it's effective.
Okay, all right. I need to compare it to another set. What else? Good. We're getting there. What else? If I only just do, for example, if I say like the fifth one, if I just say x1, what am I running right here if I only include just one of the x values? That's the same thing as doing what? What's the topic that we did right before multiple linear regression? You remember when we first started out? Yeah, Jubilee, simple linear regression. You remember when we started this whole process, when we got finished talking about ANOVA, the first thing I did was talk about simple linear regression, where it ended up being y equals mx plus b. You see only that one x, this x1 right here, is pretty much similar to this x right here. So when I start doing regressions with only one of these variables right here, it's no longer multiple linear regression. It's simple linear regression. What is your k here? This is a big review. And this first one right here, what is k equal to? When I'm looking at x1 and x2. You guys remember that that lingo? What is k? K is equal to 2.
How many x? Yeah.
Yeah, you're very good. So you see I have one x here, I have x1 here and x2 here. So 1, 2, so my k equals 2. I'm looking at two x variables. Whenever I ask you about adjusted R squared, it assumes that your k has to at least be 2, not 1. This is the case where k is equal to 1. So if I'm doing a regression where I'm only doing this right here, I'm no longer answering this question right here. Because when I ask about adjusted R squared or testing the overall model, using that F test that we're going to talk about in a second, it assumes that you have at least 2. At least 2. Now here I have k equals 2, k equals 2, k equals 2, k 3 right here, right? So when it's asking me to compare different models, when I have 2, 2, 2, 3, once I start comparing models where the k's are different, same 2, same 2, same 2, now we have 3, I can only use adjusted R squared now when I'm comparing models where the k's are different. K equals 2, k equals 2, k equals 2, k equals 3. K equals 1 is not even in the mix, right? So in the lab that you guys turned in, some of you did some of you did 4 regressions, and I guess you were trying to figure out which one should I use. So a lot of you did this. The first one was just with X1. The next one was just with X2. The next one was just with X3, and then your last one was with all 3 of them, right? So you have to really be careful that when you get to adjusted R squared and the testing overall model, I can never have choices where it's just X1 or just X2 or just X3. I need to have at least 2 of them. Now notice here what Michael told us. This one, this one, this one, and this one. It's like going through all of the arrangements of the different 2s that I could have, and then finally ending up with all 3 of those. Okay, yeah.
I'm not sure if you would give us a problem like this in the future, but I remember when I was doing the lab, I accidentally did, I don't remember how many X's there were, but there were a lot.
Oh,
And
right.
I accidentally did like every
Yeah.
single regression, like for all of them, until I went back and read the problem and it said to only use certain ones. So
Right.
would
Right.
we ever like have to do a problem like that where it's a bunch of regressions? Because I did like 11 of them.
Yeah,
And
I
I
know.
scrapped
Yeah,
it.
I heard that. Yeah. Yeah. So the only reason I did the problem that way was because it was going to be too much if you started out with if I asked you to consider all of them for that particular problem, because I think it ended up being 4. I think it was X1,
Yeah.
X2, and X4. And yeah, so I only told you to consider the first 3 of these right here because I knew that that was going to be at least 4 of them. If you have 4 of them, I think you're right. It is going to be like 11 of them. And that's just the only way I would do that to you guys is if it's like extra credit, right?
Okay.
Because that means if you add a 4 up here, then you got to go through all the variations of 2s, then all the variation of 3s, and then 4. So that's like really, really torture, right? So I would never do that to you guys like on a quiz or on an exam because it's not that it's hard, it's just time consuming.
Yeah, I was annoyed that I didn't like thoroughly read because I did all that work for nothing.
Right, yeah, because by the time you got to the second problem, it says something like, now think about all 4 of them, right?
Yeah.
Yeah, okay, all right. But I at least just wanted to revisit this right here to make sure everybody was on the same page in terms of like where these came from, where these came from. Faith, are we okay? You see where that came from? Faith? Is Faith in here?
Yes, I see, Professor.
Okay, all right. I just want to make sure you guys are awake. All right, so now, good. So now that we've established that, let's dig our teeth. And again, so some of you on the lab, you did it precisely right. So it's sounding like this is wasting time for you guys who got it, but that's okay. This is going over it again. I would rather kind of spend the time making sure everybody's on the same page here. So do me a favor. You should be comfortable running these 4 regressions now. So I just want to see what you guys remember how to do this. So go ahead and run these 4 regressions using this, 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 and this. And I don't know if you want to put the results on different sheets or you can put them on the same sheet. I don't care, but take about 3 or 4 minutes to get that. Do that. I'm going to try to load this. Okay, everybody, go ahead and do those 4 regressions and see what you can do. Now, all of them have the same Y. All of them have the same Y. So, okay. So that's 2. Now let me do the last 2. So that's X1, X2. Let me do. I did the second one. So now this is going to be. Oh, did we talk about how you guys do X1, X3? Did we talk about that? I think we talked about because I think they have to be side by side.
We did.
Okay. So I'm just going to, I can't remember if I told you guys to copy and paste or not. That's what I'm going to do.
Yeah, that's what we did in the lesson last week.
Okay. All right. So when you're doing X1, X3, notice how the X2 is right between there. So you have to reposition it so that X1 and X2 are beside themselves, and then you can do the other. Okay, good. All right, so let me change these. Anybody finish all of them yet? That one.
Yes, I did.
Good. And then finally, so in other words, the 4 that I'm doing are the ones that I wrote on the board in terms of those. So now I'm going to do the last one with all of the x's together. All the x's together is here. And notice how the y's not changing, because what we're trying to do is see which model is best in predicting the same y. So all of these y values, you know, the y column is not going to change. Y column is not going to change. All right, so I have 4 different answers here. They're kind of taking up the whole page. So, you know, you just have to keep in mind which ones are which. But if you forget, the output should tell you which ones you're considering. So like, is everybody okay with those? Everybody have those 4? Okay, so that's part of the solving this solution here. Okay, now look here. This is my first set of results. So when they're saying test the see which variables is the best model. As a matter of fact, I'm not going to tell you. Can anybody explain where I go from here? I'm trying to figure out which is the best model in predicting what's our y here. In this particular problem, we didn't even talk about what this problem was. This is a problem talking about debt, credit cards or whatever, and it's trying to see which variables contribute the most to, I guess, how much debt you have, right? And one of the columns was, if you actually read the problem, we didn't read the problem. It's in the same folder that the Excel file was. It's talking about different variables that contribute to debt. So what's your increase in salary? Because a lot of times people figure out if you make more money, then your debt is going to go down, right? But some studies have proven the more money you make, the more money you spend. If you make more than the minimum payment, right? How many frequent flyers you have, that kind of ties into like how frequently you use credit cards. And this is more or less for the MA 300 class that I created. I don't know if you guys took MA 300 yet, like a finance type of course. But I created that class, and all you do is just talk about money and, you know, different techniques in that regard. But anyway, so this is a regression to do that. So let's see. I don't know, Tatiana, what do you think? Where do we go from here?
What I remembered was looking, I believe it was the adjusted R square, and then putting those into percentages and seeing which one was the closest to, I think it's the x1, x2, x3, which one is closest to that adjusted R squared.
Okay, right. Okay, so very good starting point. So what we're going to do is look at the adjusted R squared. Now remember, the only reason we're using adjusted R squared, well, I said it, but I want to, if anybody can remind me why we're going to use adjusted R squared versus the regular R squared. Because so you see the R squared there, and you also see adjusted R squared. What in this problem lets us know we're going to be doing adjusted R squared? That's a good question. Yes, who is this?
Dana.
Okay.
You need to use adjusted R squared because there's a difference in the K values.
Yes. Very good. Very good. If we only had, if I asked you a problem and the only K's we were considering was K equals 2, K equals 2, K equals 2, K equals 2, and then that's all, then we would use R squared. As soon as that K equals 3 comes up, x1, x2, x3, you're exactly right, Dana. We start comparing models where there's different K's, then you have to go to adjusted R squared. Very good. Excellent. Okay, so everybody highlight the different adjusted R squares in each of these results. Highlight your adjusted R square. And I'm just going to maybe color code them if I can. Font color. Okay, that's that one. And what I'm going to do is I'm going to highlight the adjusted R squared and highlight the variables that they correspond to, which are down there in yellow. So let's go here. Let's go over here. Let's go here. All right. Now I'm going to go down. I have 4 of them to consider. 4 of them to consider. And that's this one here. And finally, I have this one. And this time, these are the 3 that go with that. Okay? All right, if you want to, you can kind of, and this is what a lot of you did, that was really good. You can make a chart. I don't know if you guys can see this here, but you can make a chart now of the results. All right, so I'm going to say something like, so the first one was x1, x2. All right, so these are my k's. So I'm going to do now adjusted R squared values. All right, so for the first two, x1, x2, that was the first one. And that's, and just in case you get confused, just make it so you can always refer to what x1, x2 was, increase in salary, and more than the minimum. So that adjusted R squared value is what? Barely see. Is that 61.6? I think it's 61.6. 61.6%. X2, X3. So if everybody go ahead and finish that table there. Finish that table based on what you see. X2, X3. I think that's mine under here. X2, X3. Yeah, 81.9. 81.99, so that's really 82.0. I think on the lab you guys did, I think it was like some were like neck and neck. It was pretty close. The X1, X3. That's 83.2. And I'm just taking a couple, one decimal place. Finally, X1, X2, X3. Let's see what this one is. Is that 82.9? It's 82.9. Okay, so that's what I have here. Again, I'm not sure if this is showing up inverted. I hope you can see this correctly, because sometimes it will flip me like on the other side or whatever, but I hope you're seeing this okay. Okay, is everybody okay with where these came from? Where these came from? All right, so go ahead and write your conclusion. Based on this chart, everybody go ahead and write what you think is a conclusion. Because see, the question would say which X variables or which is the best model that helps you predict, in this case, the amount of debt that you have. Which is the best model? Which is the best model? You only have 4 choices. You only have 4 choices here. All right. Let's see. Kiara, what do you think here? What's going on here? Which one do you think is the best model? Is Kiara here?
Yeah, I'm here. Sorry, I wrote in the chat.
Okay. What do you think is the best model here and why? Oh, you're in the chat. Yeah, I can't see it in the chat. I'm sorry. I have the screen kind of turned off. Do you mind just kind of summarizing what you said? Yeah. Yeah, I just can't see.
Sorry, my microphone is lagging, so it's taking a while for me to get it on. Sorry. But I said X1, X3.
Okay, why? Yeah, I think you're right. I'm just trying to get at why you said that. Because what? That ends up being the largest number out of all of these right here. Yes? Okay. So you would say whatever this represents. And so X1 represents, what was that? increase in salary. Increase in salary. And X3, according to the table, was it frequent flyer miles? I think it was frequent flyer miles. Frequent flyer miles. Okay. So these are the two variables that give the best model in predicting how much debt you have on your credit card. And so I guess typically it would look like this. Finally, y equals x. The model looks like m1 x1 plus m3 x3, see, m plus b. So that would be the model. And what you can do, you can go actually here, like if you look at the coefficients in front of that thing there, I think x1, x3, if you look at the coefficient, is really the model that looks like this. Y equals 3.06 x1 plus, I'm going back down to coefficients there, 1.02 x3 plus or minus 2568. Minus 2568. These values here I'm getting from the bottom. So adjusted R squared is up top, and then the bottom there, that just gives you the slopes that go along with that particular model. Yes.
Professor, I'm not sure if you turned off your camera like in the actual Blackboard, but is there a way you could turn it on? That way when you're writing on the board, we can switch from...
Oh. Okay, so can you see me in the little circle?
Yeah.
Okay, but you're saying in order to make it larger, you need to be able to click on the other one.
Yeah. Because
Okay.
we can't really see what you're writing on the other one.
Okay. Give me 1 second. It's kind of loading up. I think we have both of them up. Oh, you know what? Okay, I know what I'm gonna do. I can okay, so there you go. It's taking if I both of them up. So I can share the screen without sharing the camera. Okay. So well, I'll adjust that in a second if it goes slow. But is it how you need it now?
Yeah, thank you.
Okay, all right. So now this became 3.06 x1, and these numbers here just came from the values that appear on the Excel sheet where it gives you the results for x1, x3, right? There's that M1 here, there's that M3, and then there's its own y-intercept. Okay, anyway, I just want to make sure we're okay with this, all right? Any questions on that? So that was kind of what the homework was kind of expecting you to do. Now, when we're testing the overall model, though, this is where we get into the F and the T test. And the T test. So let's rehash that. And any questions on this part right here? Any questions on this part? Okay. Now, if I want you to test the significance of the overall model, now what I have to do is go back to the situation where I'm using all of the variables now, right? And in this case, all of them is just k equals 3, right? So I'm going to go back to just looking at all of the variables here. And what we do is, first of all, set up a situation where we're going to test all of the variables itself. And you may recall, it looks like this. We want to go to step 1. Right? In step 1, I'm not going to write all the definitions. I'm going to go straight for the gusto. I'm going to say M, and let's figure out how to abbreviate these for this particular problem. What's that first variable? Increase in salary. So I'm going to say M salary equals, now these are capital M's, which represent like the population. M minimum. And these are just abbreviations I'm putting for the different columns. Equals M frequent. All of those equal what? You guys remember? All of those equal what? And I can't see the chat box. So M salary equals M minimum. In other words, these population slopes, all of those equal what?
0.
0. This is 8 sub 0 here. I didn't write that. 8 sub 0. And 8 sub 1 is saying at least one of like these m's is not equal to 0. And I guess you could put another word down here that kind of summarizes all of these right here. Like I guess m reasons or something like that. I don't care about that. But at least one of these right here is going to equal to 0. And I wrote the English equivalent of those last time, but I'm going to do that here. Just go back and listen to the other lecture, right? Essentially saying all of these pretty much have no significant relationship with how much debt you have. Okay, so here I'm going to do the F test. I'm going to compare F test to F critical. So my F test. Now let's see. You already have the data here somewhere. Everybody write down what you think is the F test in this particular. We have 4 sets of results here. Write down what you think is the F test here. I have a lot of information staring at you. F test.
If you go to under the ANOVA, the regression, it says F, and then it's right under there.
Right, but see, I have 4 sets of results. Which one are you going to go to?
The one that has all of the data.
Very good.
So,
very good.
So,
Very
yeah,
good.
so it would be the one on your right here.
So is that 20.4? I'm trying to make sure I'm seeing it right.
Yeah.
Okay, good. 20.4. And my F off. Based on what you remember from last time, now here's where you got to use your F table. So everybody go ahead and write what you think should be right here. Go ahead and write what you think should be right there. You're going to have to find your F table from somewhere. And let's use 5%. Let's use 5%. Or alpha equals 0.05. .05. And all the information that you need is somewhere on this table. Somewhere on this table. Whoever has the microphone on, can you turn it off? We can hear you eating or whatever. Everybody put down what you think should go right here. Right there. All right, let's see. Megan, any idea, what number did you put inside of here? Did you find anything yet?
I'm still looking at my F table trying to figure it out right now.
Okay, no problem, no problem. Let's see. Ty, did you get anything yet? Let's see. I don't know if you guys are right.
3.10.
Let me see. Okay, I'm getting something a little different. Oh wait, I don't know. Let's see. I'm getting something a little different. Let's see. Is anybody getting something different?
I got 4.10.
4.10.
I got 3.86.
Oh my gosh, y'all. Let's see. Okay, well, where are we getting it from? are we getting it from? We're saying F. Okay, it's going to be, what's going to be the first number we go to over here? In terms of the F, it's going to be F. You're going to go over how many? Is it 3? Are you going over 3 units?
I said 3.
Because it should be K. First number you go over on the chart should be K. And what is our K here? What is our K here? I think the K should be 3 because we're looking at X1, X2, and X3, right? So we should go over 3. And how many are we going to go down? Did anybody remember the formula right here? Is what?
Isn't it n minus k minus 1?
Oh, yeah. Okay, so one of you may be right.
I also got 3.86 for the F cutoff.
Okay. 3. All right, so what is in alpha? So this is F3. What is N in this problem? What's N in this problem?
13.
13. Where'd you get that from?
It's the amount of data within each X. So it's
very
like,
good.
Yeah.
So 1, 2, 3, 4, 5. Suppose you didn't feel like counting. Where else is it?
If you just highlight the information in Excel, on the bottom it'll say the count. It'll say 13, but also in observation or the regression the observations, it says 13 on the regression table.
Right. Exactly. That's good, and I think Jubilee was saying that as well. Yeah. So if you go to, oh Lord. Okay. So I'm scrolling up on mine. Yeah. So if you go to results, you see right here, the number 13 there. I don't know if you guys can see that, but yeah, right here, observation. That's that. That's the N. Or you can just count if you feel like it, but it counted the. So we have 13 minus 3 minus 1. 13 minus 3 minus 1. The 3 again is the same K we used before, right? Now, so this becomes F of 3 comma. What's 13 minus 3 minus 1? Is it 9? Again for alpha. All right. So then on the chart here, I'm going to go over 3. And down 9. You guys are right. The guys who said 3.86. You guys are right. In my mind, I was going down to 13. I forgot it's 13 minus 3 minus 1. Did everybody see where that came from? In other words, this stuff isn't just coming out of a hat. Right? It's going to assume you have this in your notes. There's no way you can remember all of this stuff. So you're going to have this stuff in your notes. Okay, so let's do this. I'm going to do the F, remember the F distribution, what it looks like. The hump is over on the left. So if the picture that you're seeing is inverting this, the hump should be over on the left-hand side. My cutoff is here, 3.86. When you guys are doing the lab, some people put 20.4 right here as your cutoff. The 3.86 is the cutoff point that separates acceptance from rejection. Okay. Now the 20.4 is over, you have to figure out where it goes. Over here somewhere, 20.4. So does that fit in the acceptance or rejection region? As a rejection region? So we go, so when you say reject, that means we're going to always reject 8 of 0. And then we'll accept this right here. So at least one of these values has a significant relationship with debt. All right? Okay. All right. So now here, once you reject, you must go to step 2 to figure out which one does. Which one of these variables does. So we're going to go through here right quick. And I'm not going to spend too much time on this, but we're still looking at the results from K equals 3. So you're going to do 2 separate problems. 3 separate scenarios. This is M salary equals 0. Then H1, M salary does not equal 0. Right? Then you have the other one just by itself. Now H minimum equals 0, H1, H minimum not equal to 0. Okay, and I'll just do this one here, and I'll leave the other ones for you to do on your own. So now here, this is when we now go to the T test. We finish with F, and if you end up rejecting H sub 0, you have to do these right here. If you accept H sub 0, then you can stop. All right. Now, if we look here, let's see. I need a T cutoff value. What is our T cutoff value in the first scenario with salary? Oh, actually, I think when you find the T cutoff, that's going to be the same cutoff for all of these. So let's see. You have your T table. Right now, everybody write down what you think is going to be the cutoff in this problem. And let's keep using alpha equals 0.05. Yes.
I'm definitely a little behind because I was writing down the formula for the F cutoff, but I missed what the answer was. And you looked that up in the T table, and I kind of got confused, like where you found that, because I was looking at a T table and I didn't even see the number under 3 down 9. So I was a little confused about that.
Yeah, it's going to be a little different when you look at the T table. It's not going to be K comma N minus K minus 1. We're only going to have just one number for the T cutoff. Do you guys remember how you find the T cutoff? Can anybody remind me? How do you find the T cutoff? Because see, it's different than the F cutoff.
Professor, I can see you.
Oh, you can't see me?
Yeah, now I can, but it's blurry. I kept on breaking off.
Yeah. See, I think my bandwidth is okay. Yeah, we might have to kind of let's see. Can you guys see me in the bubble still? The bubble.
Yeah, but
it should be
the whiteboard.
All right. Yeah, I'm going to at least turn one of these off. Okay, let me turn this on. I'm not going to share my screen, but let me turn this off. Okay. Let me do it this way. All right, so I'm not. The more stuff I try to share, the more. I don't know if that's better, but if not, I just have to kind of redo it. But I just want to know how to find it. You can figure that out without. Anybody know how to use the T table? Yeah, Armani.
So it would be for the T cutoff, it would be the formula would be Tn minus K minus 1, which would also be 9. And then you would go on the T table to our alpha level and then go down by 9.
Okay.
You always use two-tailed.
Yeah.
Yeah, very good. That's a good point because it has one tail to two tail, and we're always going to use that two tail. Very good. So where does that take us to, Armani? If you
It's 2.6 or 2.262.
2.262. Very good. Did everybody kind of hear that? You're going up to the alpha level, but for two tail, you're always going to go to two tail, and as opposed to like two of the values for F, you're just going to go down N minus K minus 1. That's very good, Armani. And in this case, that gives us 2.262. And so our two cutoff values are what? 2.262 and what?
Negative 2.262.
Negative 2.262. Very good. Because they're going to make us have two rejection regions. Okay? And the last point here is that I'm going to compare or see where the t-test falls in this. And now each one of these different tests, I don't know if you can see it, if it's clear now, are going to have separate t-test statistics. So in the first case, let's go back to the data. What is our t-test statistic question?
Yeah, Professor, can you just move over to the, I guess you're a little so we can see like the T cutoff better? Thank you. Yes.
Okay. Okay. So let's see. If you guys, what is the test statistic in this first test case right here? It would be what? I can't really see.
1.3.
Is it 1.3 or 1.23? 1 point. So I need to make sure I'm going to the results with all of the x values and go over to t-test for the first one. If I'm looking at it right, I think it's 1.2, 1.24 or something like that, which fits here. 1.24, right? And so this fits in the acceptance. So in this particular case, I'm going to conclude that I'm going to accept x of 0, which essentially says the variable of salary, would you say does or does not have a significant relationship with debt? If you end up accepting right here, that means what? That this does or does not have a significant relationship. I don't know if you guys have any. I think we're saying it does not have a significant relationship. It does not. You're gonna have to go back to your notes to kind of figure out how we, said this particular portion right here. And so the other two are the same kind of setup. The cutoffs are going to be the same, but this t-test statistic may fall over here, over here, over here. I don't know what the t-tests are going to do in that particular case. So I just kind of felt like I just wanted to go back over it again. I hope you feel in a better place regarding this. I rarely ever do this. I say, oh, they can figure it out. They can watch the video, but I just wanted to go over the general idea again. So